Good morning and welcome back to Brodeur Land. It's Mr. Brodeur here saying hi to all the 8th grade math students, but also hoping you had a good spring break, relaxing spring break, away from school for at least a week. Even if you couldn't get anywhere because everything's like closed, maybe where you wanted to go. Hopefully you got away from school and were able to relax. But today starts the beginning of week 4, and we got to talk about what do we need to do for day 1 in week 4. So let's take a look. It looks like the question here says that below are the rules for the properties of exponents, and we need to create and solve 2 problems for each rule. So let me just show you. On your sheet or on your Google Doc or wherever you're looking, you probably have formulas on there that look something like that. And what we need to do is we need to create 2 problems that go with each of these rules. So let's take a look at my whiteboard, and we're going to talk about how can you pretty much set up and create and solve for each of these rules. So let's go over here. All right. Now right here, I've wrote down all 6 rules and also the formulas that go with them. Now before we jump in, there's going to be a couple words that I use that I need to make sure you guys remember. All these A's right here represent, and most of you guys hopefully will remember this, but they will represent what we call the base. So if I mention the word base, that's where I'm plugging in. I'm replacing the A, I'm replacing the base. Now, the other word is your exponents. So of course the X and Y's in these formulas, these are going to be your exponents. Okay, so that's just a little quick review just to make sure you're good. Now let's go about setting these up and solving. So now remember, in the problem it said you needed to set up 2 of them per rule and then solve. For this video, I'm only going to set up 1 and solve 1 just so that way I can give you an example. Now, doing exponents back in Unit 2 in the fall, what you might remember is sometimes for the bases there were numbers. Sometimes the bases had variables. So I'm going to go back and forth so you can see a lot of different examples with sometimes the basis being a variable, sometimes the basis being a number. Now for the first one, we're going to start off with a number just to kind of get things rolling. I'm going to use the number 3 for my base. Now I'm just going to use for the first exponent 2. Now I do need to use 3 again for my base. But I'm going to use a different exponent because usually the exponents aren't always going to be the same. Can they? Sure, but not always. And what the rule says is that we take the same base. So in this case, the base was 3. And we are going to add the exponent. So 2 plus 5. And then all you're going to do is add the exponents and get 3 to the 7th right there. And that's it. That takes care of your multiplication rule. Now remember, Mr. Brodeur showing you an example. You need to create 2 examples for each rule. Now division rule, or what you might remember as the quotient rule back in class. This is your rule. Now some people might remember dealing more with fractions and maybe things looking like this back in class. So what I'm going to do for our examples is I'm going to set my examples up as fractions just because that's usually what we're going to see more than maybe the division sign. But you can set yours up with the division sign if you want to. Now also on the multiplication rule, I use numbers for my bases. On this one, I'm actually going to use a variable to show you what a variable would look like. And I'm going to use the variable x right here. And I'm going to do x to the, let's do the 4th. Over x to the 3rd right there. So we got our fraction, we got our x's, our x's, and then we got our exponents. Now, when you go about this, it says here we need to subtract our exponents, but you need to be careful when you go to subtract. You need to take your top exponent and subtract it from the bottom exponent. You must do it in that order to make sure you get the correct answer. So when I go about doing this, I'm going to write down my base. My base was x, but I'm going to subtract, and usually I put the minus sign first so I don't mess up on any negatives or anything like that. And then I put my top number minus my bottom right there. And then all we got to do is subtract those numbers. So that gives me x to the first. And that would be it. So I try to give an example of using a variable, an example of using a number. You can use all numbers if you want to for your examples. You can use all variables. You can use different variations. It's up to you. Now let's take a look at a power of a power rule. Now this one right here, I'm just going to use, let's just say we use 4 for this a right here for our base. Now I'm going to put maybe a 3 right there for that exponent inside. And then for the exponent on the outside, we'll just use maybe a 5. All right. Now, with power of a power rule, what you're going to do is you're going to take that outside exponent and you're going to multiply it into the inside exponent. And so that would give me 4 to the third times 5. And all I'll do is just multiply those exponents together. So that would give me 4 to the 15th right there. So that would be your example for power of a power rule. Now, you got power of a product rule down here, which is pretty much power to a power. It just has a little bit more going on in the inside. Now, usually with these, we usually see a combination of a number with a variable. So that's what I'm going to show you guys here. I'm going to just use 3 and x, and let's just raise it to the 4th power. Now, one thing you have to be very careful when doing power of a product rule is that right here, these guys actually have, these bases right here actually have exponents. Both have an exponent to the 1st power. So before I even go about thinking to multiply that 4 in, that exponent on the outside, I need to put those ones, unless if I have an exponent. Now, if this 3 had an exponent already, that's fine. But if I don't see an exponent, I need to put those ones, because what you're doing is you're taking this 4 and you are distributing and multiplying it to the exponents inside. So really, that would give me 3 to the 4th power, because 1 times 4 is 4. And also x to the 4th power as well. And that would be my final answer right there. So last, we got our last two right here. And these ones are hopefully on the easier side. However, 0 exponent can be very misleading. Anything raised to the 0 power is 1. That's right, 1. The number 1, not 0, which a lot of people want to think. A to the 0 power, anything to the 0 power is always going to be 1. So any question I make, for example, if I did 3 to the 0, that's going to be 1. If I wanted to do q to the 0, because I wanted to use a cool variable, that would also be 1. If I wanted to make a cool funky one, you know, like 3 to the 15th power times x to the 6th power times y to the negative 7th power, all raised to 0. Guess what? You guessed it. That just equals 1 right there. So 0 exponent, get funky, get interesting with it, see what complicated mess you can get, and raise it all to the 0 power and get 1 right there. The last one is we got the negative exponent. So what happens here? I'm going to write down, let's see, what's the number we haven't used? I haven't used 8. We'll use 8 right here. And we'll raise it to the negative 3rd power. Now, what happens here is when you got a base raised to a negative exponent, you can always place it into the denominator if it's not in a fraction form. The reason why is technically right here, if I wanted to write this as a fraction, it would be currently in the numerator. And so when you place this 8 to the negative 3, which is currently in the numerator, when you go and place it into the denominator, what it does is it changes the sign of that exponent from negative to positive, just like it says right here in that formula right there. So that would be my final answer right there. If you wanted to use a variable instead, your variable would stay the same, but your exponent would change its sign from negative to positive. So that's an example for each of these rules for exponents. So all in all, I hope this helps clarify how to set up, how to use the rules properly. Remember, Mr. Brodeur just showed you one example for each of these. You need to show 2 examples and solve for each of these rules. So make sure if you got any questions, ask your teachers, ask me, email us. We'll be glad to answer any of your questions. But until next time, Brodeur out. Peace.